All right, so today we're going to talk about data structures and what to do with data that's structured for human eyes versus data that's structured for computer imports. But before we dive into talking about how to structure or restructure your data, first we're going to talk about some very basic data cleaning best practices. Um, there are really just 2 points that are essential for cleaning your data. First is to never delete the originals. This means that, if you're working with your data in Excel or something like that, save it with a new name or save the transformations that you make onto a new tab. Never delete your original. In the era of the internet, where it's pretty easy to download data sets that you find there, you can usually recover your originals, but you can imagine the situation that you get into if you only have one copy and then you change it and you made a change that you want to undo. So never delete your originals. Second is document how the values were altered. Now, if you're using something like Python or R, this is documented for you in the script that you write. But a lot of us, for these types of projects, are going to be doing our alterations in something like Excel or Tableau, in which case every time you do something, you just want to make a note. They don't have to be elaborate, they don't have to be anything like that. You just want to remember exactly what you did. So this can be keeping a document on the side that says, step 1 or just 1 period, separated the columns to separate the meal and the price or something like this. Keeping track of that will save you a lot of headache in the long run. I speak from experience on that point. All right, so let's move on to talking about data shapes. So you're going to come across a lot of data shapes in your lifetime. There are a lot of shapes out there, but most of them that we're going to be dealing with are what we call rectangular. This means that they operate on rows and columns, or observations and attributes, records and categories, instances, variables. All of these are interchangeable. All of them mean, the data that's along the row is one instance or observation or record. The data that's in the columns should always be your variables. Sometimes these are called categories or attributes. Rectangular data mostly comes in 2 flavors, although there's one slightly more rare flavor out there as well. But mostly you're going to have Excel, which is a proprietary format that's owned by Microsoft and has a lot, is often to blame for the breaking of character encodings. Excel files are really interesting. They're zipped together, so it has to be read as an entire file. You can't read half of an Excel file at a time. You have to read the whole thing. CSV are much more flexible in the sense that they work in a much wider variety of programs. So if you have a CSV, you can load it into pretty much anything because CSV is not proprietary. The character encodings are what you specify. So you might specify your character encodings to be something like UTF-8 or UTF-16. Don't worry about what those mean right now, but just know that when your emojis get garbled going from one platform to another, that's part of what's going on. So CSV files, you've no doubt seen, are comma-separated values. What this means is that every value is just separated by a comma. So rather than having a hidden marker that separates your values, you have your comma. The other format that you might have seen are TSV, and these are tab-separated values. They're similar to CSV, they're non-proprietary, can be opened by a wide variety of software packages, but rather than separating the values on a comma, they're separated, you guessed it, on a tab. There's a couple other formats of rectangular data, but for the most part, that's what you're going to be working with. Some data is dictionary-like. This is JSONs, Avro files, headless databases. Don't worry about these for the time being. If you ever get your data as a JSON and you are not proficient with dealing with it yet, there are plenty of online sites that will help you transform your JSON into a CSV. And some databases are relational databases. This is actually the format that Tableau is based on. So when you pull in a data set and you drag it over to your data pane, and then you drag a second one, like we did in the restaurants tutorials when we added the lat long to our survey data, it immediately joined it. We're going to talk more about that in the second tutorial today, but that join indicates to us that Tableau is operating as if it were a relational database. It's expecting that one table links to another table, or one rectangular data shape links to another rectangular data shape on a shared, unique identifier. One way that I like to think about this is thinking, I link multiple worlds through me. I link my job and my family, and I am the unique identifier that links the two of them together. Okay. There's a lot of ways to think about it. We will talk more about linked data later on. Okay, so let's move on and talk about messy data versus unstructured data. So when we were looking at the 311 data, that was really messy. There were missing data points, there was an inconsistent variable names, an inconsistent taxonomy, the codes were incomprehensible at times. This data was very, very messy. But it was messy in the sense that the data was messy. The structure was fantastic. That is a well-structured data set. So there's a difference here between cleaning up the data, so cleaning up the actual values in the data set, and cleaning up the structure of your data. And today we're going to talk about the structure. Unstructured data oftentimes is meant for human eyes. So we make a lot of data sets that are really just meant for humans. When we say that data is structured or that it's tidy, we are talking about data that's ready for a computer import. Okay? So let's look at a little bit of what we mean by that. So the data that we're looking at here is in actually two tables. So when we are talking about tidy data, there's three principles, and these three principles come out of a paper that was written by Hadley Wickham, who was instrumental in developing the R programming languages package Tidyverse, which is kind of a data science package that's in widespread use. All right. And in this paper, he writes that all data should have these three principles: that all of the observations are rows, all of the variables are columns, and there's only one type of observational unit per table. Now, that's a pretty sparse definition. He goes on in the paper to talk considerably more about it, to talk about it at length. We are going to talk about it here. And what we are going to look at are these two data tables and how they're related to each other. So the first data table is about people's children. So we want to know, what are the names of children? This first table here is about, people's children. So we have 4 children, but we have only 3 adults. And this requires us to have 4 rows. We have 4 observations because each observation is 1 row. So Wanda has Maria, Maria is 12. Wanda also has Lacey, and Lacey is 15. Floyd has 1 child, Marcus. Clyde has 1 child, Luella, right? So each child gets their own row, even though this creates redundancy over here in the names column. When we're talking about tidy data, redundancy is no problem. Now, if we look over here, this is a table about people and their occupations. So this is the same people, but here we only have 3 rows because Wanda appears once. She has 1 education status and 1 occupation. Floyd has 1 education status and 1 occupation, and so does Clyde. We never need to repeat here because we're not worried about, we don't need to repeat here because each observation fills 1 row. It's not that any of these would have to have a column. It's not that Wanda's education is chemistry and mathematics, in which case we would need another entry for Wanda. It would look more like this table, where Wanda has 2 unique items for the child variable. Wanda only has 1 unique entry for the education variable. Therefore, this table only requires 3 rows, whereas this table requires 4 rows. Now you might see that we might want to combine these. Maybe we want to ask a question about the relationship between people's education and the ages of their children, or something along these lines. We could do that here, and we would end up with 4 rows because our biggest data table has 4 rows. So Wanda having a chemistry degree would be replicated here as well, because to join these 2 data frames in the most common way, which we'll talk about that in just a minute, the different types of joins, we end up having to replicate Wanda here multiple times, whereas Floyd still has 1 education and 1 occupation. Now, if Floyd had 2 occupations, let's say that instead of this, or let's say Clyde has 2 occupations, then we would have Clyde, who is 28, who has mathematics and data analyst. He would still have Luella, but Luella would be duplicated, and so would Luella's age, right? Because anytime that there's at least 1 unique item here, then everything else gets replicated. The only time that you don't want repetition is when you wouldn't have Clyde 28 mathematics engineer Luella, Clyde 28 mathematics engineer Luella. You know, that's what you want to avoid. And what that would look like here on our original table is we would have Clyde 28 mathematics data analyst, right? So if we were joining these 2 tables, this join would make Luella duplicate as well. And then joining these together to make this table would be a full inner join. Okay, now we're going to go and look at some hands-on examples that'll hopefully make this a little bit more concrete. So let's say that you work at a place that has a meal plan. Congratulations! What we have here is an excellent way that that meal plan would be distributed for human consumption, so that everybody in your office can understand how to deal with the meal plan. So this meal plan has a few problems when it comes to our data though. We look here and we have 2 columns, or 2 rows, 3 rows, without data or headers. That's probably not going to be terribly helpful for us. Ultimately, we're probably going to want to get rid of that. Most of our data analysis programs assume that the first row is the header. However, Tableau has a handy way of dealing with that. The second thing that we notice is that we have 2 rows of headers. Now, interestingly, the second row of header is actually a redundant piece of information. Now, this might be a really helpful piece of information for a human, but it's not a very helpful piece of information for a computer, which will automatically be able to tell you what the day of the week is based on the date. So if you want to make a chart of all of the meal plans and what is served on Monday, you don't necessarily have to have a Monday variable. You can just ask a program such as Tableau to find all of the Mondays really easily. So that Monday, that day of the week row is actually really redundant. Okay. Another thing that we notice is that we have data in our headers. This is not what we wanted. We already said that we can't have data in our headers, and you might be saying, that's not data, that's the day of the week. It actually is data. We can group it together, and we can say, what's the date? And if you can group it together, it would be better expressed by saying date. Now, if you were to distribute this in a tidy format without the day of the week and with the date in a column, it'd be really hard for humans to read it. So the way that it's formatted now is perfect for a human, not perfect for a computer. So this is not to say that it's wrong, just it's wrong for our purposes. Okay, so we could group all of these into the date, which means we have data in our headers, and we're going to need to pivot our data set. The next thing that we notice about this is that our omelet has the price after it, which means each cell has two different pieces of information. That's not what we want. We want to make sure that each cell only has one piece of information. Okay. If you haven't opened this up already, go ahead and download this from the tutorial notes. And we are going to go ahead and clean this by hand. We're going to clean it in Excel, not Tableau. We'll do the next one in Tableau. All right, so go ahead, take a pause here and download this and make sure that you open it in Excel or Google Sheets. You can do the exact same transformations in Google Sheets. It's not a problem. The only thing is the buttons are located in a slightly different spot. But all of the buttons do exist, I promise. All right. So, welcome back. I assume that you have downloaded this for yourself and you are looking at it on your screen. Okay, let's go over here to Sheet 1, where we've already copied this data set over without these three first columns. I just made a copy here. The reason I made a copy here is that I wanted to be able to clean it manually so that we can see what's going on with our data. Okay. So what we are going to do is we are going to take our breakfast, lunch, and dinner. We're going to copy them here. Okay. We're going to take our location and we're going to copy it here. One thing that we notice that's really helpful and that we're going to take advantage of is that lunch is always in the dining hall and dinner is also always in the dining hall and breakfast is always in the common room. So these are both going to be replicated with the same pattern, as you'll see. Okay, so then we have our date. So this is going to be 5/6/19, and then 5/6/19, and 5/6/19. All right, and then our first option is an omelet for $5.50, and our price is 5.50. You might note that I have removed the $sign from this, and the reason for that is I assume that the prices are all in the same currency. So it actually makes more sense for me to put the price here than attached to every single instance. Okay. I also have a salad and I have chicken. I'm going to be really lazy and I'm going to copy those in that way, and I'll show you some cool tricks for how to deal with that. The next thing I'll do is I'll copy Tuesday and I'll just add it to the option here, copy Wednesday, add it here, copy Thursday, add it here, Friday, add it here, Saturday. Oh, I copied Thursday twice and never Friday. Copy Friday, add it here. Oh, no, Excel is not my strength. Okay, I hit escape to remove that square highlighting. Copy Friday, copy the Saturday, and we will copy Sunday's meal plan. Okay. You'll notice this is a lot of work. There are tools and techniques that'll help you do this more easily. What we're doing is called pivoting the data. Okay. Now I'm going to fill in the dates and copy that. Now let's see if Excel is smart enough. Nope, it won't do it for me. All right, so 5, 8. And go ahead and keep filling these in. All right, and once you have all of your dates filled in, go ahead back up here and delete these rows because we actually don't need them anymore. Okay, so the first thing that I'm going to do is copy this all the way down. I'll show you a cool trick. So if you do this first with location, because location has data immediately to the right of it or to the left, you just have to have data immediately touching. And you double click once the bottom right hand corner turns black, once this cross turns black here, double click there and it'll fill the pattern all the way down. Do the same here now that there's data touching it to the right. Once the crosshairs turn black, double click and it'll fill all the way down. Excellent. All right, so the next thing that we need to do is we need to split all of these text to columns. So I'm going to go here to Data on Excel, and I'm going to select Text to Columns. Depending on the version of Excel that you're using, text to columns might be somewhere else, but no matter what you're using, it's called the same thing. It's always called text to columns. I'm going to click Next. I'm going to tell it it's separated on a comma, and I'll click Next and then Finish. Unfortunately, this left the $sign. What's interesting about that is that if you look up here in the viewer, this $sign is not actually in the data. It's something that Microsoft Excel thinks it's helping us with. So this is very unique to Excel. If you're in Google Sheets, it might not work the same way. But I'm going to highlight all of these cells. I'm going to right click and I'm going to say Format Cells. And then I should get a dialog box that pops up. I'm going to say that it's a number. And right now it thinks that it's currency. So I'm just going to say that you are a number and use 2 decimal places. Okay. And then that removes all of these columns. Now that we have successfully cleaned this data set by hand, we're going to move over to a more complicated and more realistic data set. We're first going to clean it by hand, and we're going to pivot it in Tableau. So go ahead and move over to the next video where we're going to work on data structures. Enjoy!